talk about our last lesson, which is kind of just bringing in a lot of the stuff that we've already talked about and looking at those relationships specifically within the coordinate plane. Not every question will have a graph. Some of it will just be those coordinate plane relationships and those contexts. We'll be looking at parallel lines, perpendicular lines, things like that, as well as comparing some of these equations. So with some linear relationships, we are given two equations, and we want to know how many solutions there will be to this system of equations. Well, off the bat, you don't need to solve for the solution to be able to determine how many solutions there are. Okay? It's not asking what the solutions are. It's asking how many we have. All right? When we're dealing with the system of linear equations, these are both lines, they're straight lines, our only options are either going to be 0, 1, or more than 2, also known as infinitely many. The only time 2 would be a possibility is if one of these was a quadratic. If I had a quadratic equation and a line that passed through the quadratic, then I could have 2 solutions to that system because they intersect twice. Or I could have one solution to that system because they intersect once. Or I could have no solution to that system because they don't intersect at all. So the only time 2 is a viable option is if one of these was squared. Okay? That's the only way. So we can ignore that, and we're just focusing on 0, 1, or more than 2. What do I know about systems that have no solution with 2 lines? What do I know about those lines? If they have no solution to the system. Systems that have no solution. What do I know about those lines? They are parallel. Okay? So if it's 0 solutions, then my lines here are parallel. Okay? If it's 1 solution, well, the lines intersect somewhere. What if it's more than 2 solutions? What if it's infinite many solutions? What do I know about the lines? Yeah, they're the same line. Okay? So, if the lines are parallel, what do I know about the lines? What do they have in common if they are parallel? Slope. Same slope. But what's going to be different? Okay? So, if I have the same slope, but different y-intercepts, then I'm going to have 0. Okay? And then if they're the same line, well, it means they're the same line. Same slope, same intercepts. Same everything. Okay? And then if it's not either of those, then it's going to be one solution. So we just got to figure out and look at the pattern. All right? Now, this is already set up for elimination. If I wanted to do elimination, what would I do for that equation? What would I do to that equation? Now, if I was going to actually solve, I would multiply by -2. But for the sake of pattern recognition, let's just multiply it by 2. 2y plus 6x equals 4. That's all the math that I need to do to answer my question. I don't need to do anything else. I just need to look at the pattern. I need to look at the coefficients and the constants. Do those 2 lines have the same slope? How do I know that they have the same slope? And 2y. Both coefficients have to be the same. The coefficient of x and the coefficient of y. They both have to be the same. And since they are both the same slope. Okay? Let's verify this. So if you're having a hard time understanding why or seeing that, let's just take a look. If I wanted to put this in slope-intercept form, I would be subtracting 6x. Well, since I have 6x on both of those, I'll be doing the same thing for both of those. So I'll be subtracting 6x. I get 2y equals negative 6x plus 4. And then I would divide everything by 2. Well, since both of these have a coefficient of 2, both equations, I would be following the same exact steps in order to get my slope of negative 3. So both of those have a negative 3, and I know that because the coefficients are the same. Now, to answer the question, I don't care what the slope is. I just need to know that they will be the same because the coefficients are the same. So now I know it's not going to be one solution because I know they have the same slope. If they had different slopes, then I'd be done. It's one solution. But they have the same slope. So I have to determine, do they have different y-intercepts or do they have the same y-intercepts? What part of my equation do I look at to see if the y-intercept is going to be different? The 4 and the 3. The constants. The constants give you a hint as to the y-intercept. Those aren't going to be your y-intercepts because you still need to divide them by 2 because of that coefficient on the y. But they give you a hint as to what the y-intercept is. And since they're not the same value, then they're not going to be the same y-intercept. And so since they have different y-intercepts, the solution is 0. Not the solution is 0. There are 0 solutions. They're parallel lines. The coefficients were the same, but the constants were different. They're parallel lines. It's all about making connections to the patterns that are there with the equations. And we'll be having that same thought process with a few different questions too. Like this one. In the system of equations above, a and b are constants, okay? A and b are some number. We don't know what those numbers are. If the system has infinitely many solutions, what is the value of a? So based on what we looked at before, what do I have to have with the equations in order for it to be infinitely many solutions? Same everything. Same y-intercept, same slope, same coefficients, same constants, same everything. Everything has to be the same. Because in order to have infinitely many solutions, we have to have the same equation. Okay? So I need to figure out what values I could plug in for A or B that would make it the same on both sides. Now, they only really care about A, so that's all we need to focus on. Okay? Is what value of A would make it the same. Okay? Now, when we look here, we need to look at a term that we can manipulate within both of these. We're going to use 3s and negative 15s as kind of our anchor. If we can manipulate our equations that those are the same, then we can compare the constants to figure out what adjustment we need to make for A. Okay? So what can I do to this equation so that 3s turns into a negative 15s? Multiply by negative 5. Okay? So I end up with negative 15s plus 10t equals negative 5a. And then this equation is still negative 15s plus bt equals negative 7. Now, just for funsies, through some inspection, what does b have to be? What would b have to be in order for those to be the same? 10. Okay? Because it has to have a coefficient of 10. So b has to equal 10. Now, we don't need to know what b is, so that was just for fun. Okay? We need to focus on this part. Okay? Negative 5a has to be the same as negative 7. How do I show in math that two things have to be the same? How do I show that two things have to be the same? Use words.
Oh, graph.
Equal.
Plus.
Show that they have to be equal. Negative 5a has to be equal to negative 7. That's the only way that we can get infinitely many solutions. So how do I solve for a?
Plus.
Not plus.
Isolate it.
We need to isolate a by doing what operation? Division. Divide by negative 5. Because we have negative 5 times a. We undo that multiplication with division. And a equals 7/5. There's our value for a.
Is it okay to leave it as
Absolutely. You have to leave it as an improper fraction. If you have a student supplied response, which is, okay, and then you've got all the bubbles down here, right? That you fill in? Okay. If you turn it in as a mixed number, okay, which is 1 and 2/5, all right, and you go to put it into your student supplied response, you would put 1 and then 2 and then a slash and 5, and they're going to read that as 12/5, not as 1 and 2/5. So you have to leave it as an improper fraction so that you can put it in properly and they read it properly. Okay, so always leave your fractions in proper. Always simplify your fractions, but always leave them as improper. And I'm pretty sure on student supplied responses, there is never a negative answer. Because I'm pretty sure one of the bubbles doesn't even have a negative. Okay? So if you get a negative answer, you mess something up. Go back and fix it. Alright? So no mixed numbers, no negative answers. Alright? On the student supplied responses. The graph of line K is shown in the XY plane. Which of the following is the equation of a line that is perpendicular to line K? So that's line K over there. What do I know about perpendicular lines? They do, but there's something very specific about the way that they intersect. Perpendicular lines.
Does it create like an angle?
Granted, every intersection does, but it creates a very specific angle.
Right angle.
A right angle. Perpendicular lines make right angles. What about the equation makes it so that they form a right angle? A part of our lines that have to be a very specific relationship.
The x will y cancel.
It's not so much with the y-intercept.
Opposite.
Close. Opposite reciprocal. The slopes have to be inverses, multiplicatively and additively. Okay? So perpendicular lines have opposite and reciprocal slopes. So for all of these, I don't care about any of that information. I only need to look at that. I need to find a line that has an opposite reciprocal slope to the one that's graphed. So I have to know what the slope of the graph is. What's the slope of the graph line? Slope is rise over run. So is it going up and down by 2 or by 1? 2. So we're going down 2, right 1. So my slope is -2 or -2 over 1. So since my slope is negative, the opposite is going to be what?
1/2.
Be positive 1/2. So I see a negative slope. I know the perpendicular line then has to have a positive, so I can knock out those two. I know that the slope is -2, so the reciprocal is going to be a positive 1/2. Perpendicular lines have opposite reciprocal slopes. Change the sign, flip your fraction, match it up. Parallel lines have what kind of slope? Parallel lines. The same. Parallel lines have the same slope. Perpendicular has opposite reciprocal. Okay? Voter registration drive was held in town Y. The number of voters V registered T days after the drive began can be estimated by the equation V equals 3,450 plus 65T. What is the best interpretation of the number 65 in this equation? What part of my equation is 65? Total is V.
Number registered or
Well, T is days after the drive began. What part of my equation is 65?
The number of days.
Ignore the context for now. I want you to we're going to come up with our own before we pick that. What part of my equation is 65? Delete everything else except for this.
it's what it increases by. I don't know.
It's what it increases by. It's its slope. Yeah, that's exactly it. It's the rate of change. So again, when we're interpreting these equations, come up with your own idea of what the number represents. If it's part of the slope, if it is the slope, then recognize and identify, hey, that's my slope, which is rate of change. How much it is changing by. If it was 3,450, that's our constant. That's our starting value. So you have to think about what part of the equation it is and then add in the context. Because if you just go through this list of readings, sometimes you get lost halfway through and you be like, I don't know what it's talking about. But if you can go in with an idea already in your head of what you're looking for, it makes it a lot easier to start eliminating and picking the correct one. So I need a rate of change. Okay? And then I need to ask myself, because sometimes we'll have multiple things that are rate of change. What is it changing by? What's that interval? So what does T represent? Days after it started. So 65 times days after it started, we're looking at going up. So, or let's use the word increasing. Increasing by 65 each day. Okay? We're going to increase by 65 each day. That's what that 65 means. We came up with our own understanding. 65. It's increasing by 65. T is days. Every day. 65 every day. So, A, the number of voters at the beginning of registration. Is that telling me 65 a day? No. The number of registered voters at the end. Is that telling me 65 a day? No. The total number of voters registered during the drive. Is that telling me 65 per day? No. The number of voters registered each day. Is that telling me per day? Yeah, there it is. Okay, so 65 per day. Figure out which one matches. Okay. Uno más. What type of system has no solution? Well, we're going to assume that all variables are real numbers unless otherwise specified. So, we looked at this.
P or MP. It's there.
Parallel lines. Same slope, different line. So, no solutions means we have parallel lines. Same slope, different what? Y-intercepts. So what part of my equation do I look at to determine that the slopes are the same? Right? But I'm in standard form. I'm not in slope-intercept form. So I could rewrite it in slope-intercept form, but that would be a lot more work. So what part do I look at to determine whether the slopes are going to be the same? I don't care what the slope is. I just need to make sure that they're the same. What about the left side?
The left side.
Okay, so I'm looking at the left side, and I'm looking at this side, right? So be a little bit more specific. What do I need to ensure is the same over here on the left? I've already got X's, I got Y's, what else? What do we call these numbers? Not constants. The other C, coefficients. I need the coefficients to be the same. Okay, well, I need to make sure that these 4 things are the same. So I need to figure out, well, what can I multiply 2 by in order to get 9? Or what can I divide 9 by in order to get 2? If through inspection you can't figure that out, easiest thing to set up is a proportional relationship. We'll talk about more about proportions next week. But the ratio of 9 to 2 has to be the same as 14 to A. You should be able to do the same thing to get to each of these, or to here, or to here, or back, or this way, or all around. That relationship has to be the same, the y coefficients to the x coefficients. So if we set up a proportional relationship, we can just solve for A. Cross multiply. Negative 9a equals negative 28. Divide. I'll be positive now. Positive 28 over 9. That's our value of it.
What did I miss?
What did you miss?
Cross multiply.
So basically, it's a shortcut for clearing your coefficients. Okay? So if I want to do it the long way. Alright? In order to clear your denominators, you're going to multiply by your least common denominator. In this case, our least common denominator is the denominators, negative 2a. So I'm going to multiply both sides by negative 2a. Over here, when I multiply, well, the 2's are going to cancel out. So I have negative a times 9. Negative a times 9. Over here, the a's and the negative will cancel out, leaving me with negative 14 times 2, which is the negative 28. That's how we clear the denominators, and then we're going to divide by our coefficients in order to isolate our variable. And that's it, I think, right? Yep, awesome. Okay? Questions, comments, concerns, queries, conundrums? All right, so you've got 5, 10, what, 15? Is it either 50 or 55? 50? Okay, so we got 15 more minutes. You can start on